So here we have our list of exponent rules. Let a and b be positive numbers, and let x and y be real numbers. Then all of these properties are true. Let's go through them quickly. Common bases multiplied together, we add the powers. If you have a quotient of common bases, b to the x over b to the y, we subtract the powers. I like to think of this one in terms of, I'm always going to subtract if I have common bases. I'm going to subtract and put the answer where the biggest one was. That way I don't have to worry about negative exponents. That'll make sense in just a minute when I do this example. If I have an exponential function, b to the x raised to another exponent y, then I multiply the powers. A power raised to a power, I multiply. If I have a times b raised to the x power, then each of these terms in here, note this is a product. This is only true if it's a product. Each of these terms in here also gets an x as a power. And just think about like kind of distributing. If I have a quotient raised to the x power, each of these also gets an x. A negative exponent is here. If you have a negative exponent, it flips the position. So let's try one. Simplify this super fun looking exponential problem. Looks really nice. So 6x cubed y squared x to the negative 8 divided by 15x to the 5th, y to the 4th, y to the negative 4th, and all of that is raised to the negative 3 power. Now, there's lots of different ways to do this. You can really use these rules in any order you want, as long as you do them correctly. However, there is a suggested order. If you remember the order of operations, please excuse my dear Aunt Sally. What does the P stand for? What? Okay, good. P stands for parentheses. So, and when you did order of operations, please excuse my dear Aunt Sally, or PEMDAS, you worked inside the parentheses first and cleaned that up. So that's sort of what I recommend to students. It makes things less complicated. You don't have to do that first, but that's what I recommend. And actually the first thing I recommend you do is you address that negative sign right here. So that's what I tell students first is if the whole fraction is raised to a negative power, we're going to take care of that negative. We're going to flip the fraction and use a positive power. And the rule I'm talking about is this one right here. So like, in this case, I'm using step 1. So you're not touching anything inside, like cleaning up that in any way. All you're doing is taking the numerator and rewriting it exactly the way it's written as the denominator. And the denominator will be rewritten exactly the way it was written, but now it's in the numerator's position. So let's do that. So 15x to the 5th, y to the 4th, y to the negative 4th, and then 6x cubed, y squared, x to the negative 8. Notice, I did not clean up anything at all. I just rewrote exactly what the numerator was, but now it's in the denominator's position, and so on with the denominator. And the power was a negative 3. But looking here, that negative x becomes a positive. So this is now going to be a positive 3. And we put an equal sign because that is equal. Now, we're going to work inside the parentheses. You can do lots of different things. Again, the order doesn't really matter. I like to clean up with the numbers first. So what I would do next is address the numbers. So we have this rule that says, if you have A times B times C, and you're dividing by B and D, the different things multiplied together, you're allowed to cancel the factors they have in common, as long as it's all multiplication. So then you'd have like A times C over D. So I like to look at that 15 over 6 and reduce that. So it may be helpful to write the 15 in terms of its prime factorization, which I'm going to do in smallest to largest, 3 times 5. And the 6 is 2 times 3. If we do that, we see that, yes, they do have a factor in common. We can cancel at 3. So that's sort of what we're going to do over here. We're going to say, well, this is 3 times 5, x to the 5th, y to the 4th, y to the negative 4th. And then instead of the 6, I'm going to think about this as a 2 times a 3. X cubed, y squared, x to the negative 8. I still have this power of 3 on the outside. I'm going to carry him along. But now I'm going to cancel that term they have in common. So I end up with 5x to the 5th, y to the 4th, y to the negative 4th as my numerator, 2x cubed, y squared x to the negative eighth as the denominator, and the whole thing is still raised to the third power. Again, there are lots of different order, different ways you can do this, different order you can apply. The next thing I like to do is get rid of anything that's negative. I have an easier time adding than I do subtracting, especially subtracting a negative. Remember, minus a negative becomes a positive. So I'm going to take everything that's negative, any power that's negative, and I'm going to flip its position. So I'm just circling them just so you can identify what I'm doing. So I'm going to rewrite the 5. I'm going to rewrite the x to the 5th and the y to the 4th. And I'm not going to write that y to the negative 4. I'm going to put that in the bottom. So let me write the things that don't move first. So these things didn't move, but that y to the negative 4th now becomes a y to the 4th down here. And the x to the negative 8 that was in the denominator becomes an x to the positive 8. Let me put a plus so you can see what I'm doing. Plus 4, like this. And there's still a 3 on the outside. So let me circle so you can kind of keep track of what I've just done. I still moved these guys. Let me actually color code them a little better. I'm going to color circle one in green. You can see the green one, it still has an x and the power is still an 8. The sign has changed though because I've changed the position of that term. Everybody got it? And if you look at that, that was the rule that a to the negative x is 1 over a to the x, and 1 over a to the negative x is a to the x. That was the real rules. Okay, so now let me rewrite it without the circles and the plus signs. I'm going to go do one more operation. Now I'm going to combine things in the numerator. So I actually stopped numbering this, but number 1 was, if it's a fraction, flip it. Number 2 was clean up the integers. Number 3 was make all exponents positive. Sorry, I should have been writing this. Okay, so number 4, again, this is just my personal preference. I'm going to clean up the numerator, just looking at the numerator only, and then I'm also going to clean up the denominator as 2 separate little pieces. What I mean by that is I'm going to look and say, do I have any variables that are the same in the numerator? Yes. So let me circle them in. I'll do green this time. So I have x to the 5th and x to the 8th. So I'm going to use a rule right here. My rule is going to be a to the m times a to the n is a to the m plus n. I think the letters were x's and y's earlier, but I have x's and y's in here. I don't want to confuse you. Does that make sense? So I'm going to do this step. I'm going to do 5x. Now instead of x to the 5th and then y to the 4th, x to the 8th, I'm going to look at the x to the 5th and the x to the 8th together. I'm going to have x to the 5 plus 8 using that rule. So circle it. So this x to the 5 plus 8 came from multiplying x to the 5th times x to the 8th. Okay. I'm going to do the same thing with the denominator. So I got my 3 outside. My denominator, I have, let me use blue. Looks like I have 2 y terms. Y squared and y to the 4th. So let's actually talk about these since those are smaller numbers. Y squared and y to the 4th. Y squared, y to the 4th. Well, y squared is really 2 y's, right? Y to the 4th is how many? Okay, good, 4. Okay, now drop the parentheses. How many y's do we have? Y to the 6. You see why they add? Awesome. Okay. So this is 2x cubed. Now have y to the 2 plus 4. See? So that's that property right here. Okay, so let's just write down what that is. So this is 5, then I have x to the 13th, y to the 4th, over 2x cubed, y to the 6th. All of that is cubed. Got it so far? Everybody good? Okay. So now, the next step, I guess I'm calling this 5, is look at terms in both the numerator and denominator. And reduce those. So notice I only have a single term with x in the numerator and a single term with y in the denominator, but I do have x's in the numerator and denominator. So I'm going to circle it, x to the 13th and x cubed. And I'm also going to circle the y's. I guess I'll use this fun color. Y to the 4th, y to the 6th. Let's look at the y's over here. If I have y to the 4th over y to the 6th, and you're not sure about the rule, you can always look up the rule, but let's just play with it. If I have y to the 4th, I have 1, 2, 3, 4 y's. Y to the 6th is how many? Okay, 6. And I can cancel, right? And so I cancel, there's a y on top, I can cancel with 1 on bottom. And I end up with 2 y's remaining. Where are they? Where? Okay, they're in the denominator. Y squared. So if you look at this, if you look at the powers, your rule actually says, something, I don't know what letters I had, A over B. No, I have that written. It was B and X's. Okay, just kidding. Hang on a second. Let me write it the same thing I had earlier. We had B to the X over B to the Y was B to the X minus Y. We subtract the powers. So you could have done this as Y to the 4 minus 6. Y to the negative 2, but then you have to remember to flip it. So what I like to do is I like to subtract the powers, biggest minus smallest. So 6 minus 4, and that's 2. But where was the biggest power? In the bottom. So I'm going to make sure there's more y's in the bottom, because that's what happened right here when I canceled, right? That's the only place the y's are left. So put the solution where the biggest power was. Okay. So that's going to be our strategy. We're going to rewrite the 5, rewrite the 2. Let's look at the x's. I have x to the 13th on top, x to the 3rd on the bottom. So I'm going to subtract, but I'm going to do the biggest number minus the smallest number. So I'm going to do x to there were more x's on top, so 13 minus 3. Does that make sense? Why am I putting it on top? Okay, good. Because there's more x's on top than there were on bottom. If I were to list them out the same kind of way I did over here with the y's, I'd see I have 13 and I'd have 3 and I would cancel, 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 cancel. There's going to be x's remaining still on top. And then the y we do the same way. We say, okay, well, I have y's on top and on bottom. Where are there more y's? Okay, in the denominator, good. So y, and I do 6 minus 4. I'm still subtracting, but I'm putting the term where the biggest one was. Close my parentheses, and I have a 3. Well, I have 5x to the 10th over 2y to the what? You say 2? Okay. 2y to the 2. And all of that is still to the 3rd power. How do we feel so far? Now look, the inside is as simplified as we can get it. Remember the order of operations, we work inside the parentheses first. You don't have to, the rules still work the other way, but it's very convenient to clean up that way. So the last step we're going to do, this is number 6, is we are going to bring that power, apply that exponent on the outside. Okay, so it was a over b to the x, I think is how it was written earlier. It's a to the x over b to the x. That means every single thing inside that parentheses is going to get that 3rd power. So 5 cubed, x to the 10 cubed, 2 cubed, y squared cubed. Do I see it? Well, then we'll get to use more exponent rules. 5 cubed is 5 times 5 times 5. That's 125. And then here, if you have a power raised to a power, what do? Okay, you multiply. So that's x to the 30. On bottom, you get 8. Y to the what? Multiply 6. Okay. Remember, let me do that one because it's a little bit smaller. That's like y. There are 3 of them. 3 sets of parentheses. Each of them has 2. If you drop all the parentheses, you do have 6. Everybody got it? So this is our final answer. How do we feel? Okay, good. Awesome.